Hi, everyone. My name is Asaf. I'm not from Kansas City. I'm from Chicago. But my wife and her entire family is in the Kansas City area, so I do have to follow the Royals and follow the Chiefs and support them, mostly because I'm from Europe and I'm mostly interested in the MLS anyways. Sporting is good. Especially since the Fire are really bad right now. So I want to talk today about the IaC tooling. First, I guess I should present myself. My name is Asaf Blubshtein. I work as a solution architect at Env0. We're a DevOps platform engineering taco company. I will start with our old discussion about tools with just I want to be transparent. We do back one of the open source tools called OpenTofu. Is anyone familiar with it? Heard of it? That's good. I'm not trying to sell anyone about OpenTofu or anything like that. We're going to talk about the ecosystem in general. And I think I might have to just stand here then. OK. Raise your hands. How many people here are using infrastructure as code to deploy their infrastructure? How many people here are using more than one tool to deploy their infrastructure? OK. So for those that might not be leveraging infrastructure as code as much, infrastructure as code, especially due to the cloud-native nature of our deployments and our environment and our infrastructure, it's becoming really the de facto standard for managing our infrastructure. It allows us to be more agile, to engage developer self-service, and identify changes easily. Everyone loves Git blame, and integrate with existing CI/CD pipelines. Some of the challenges that we're constantly facing are that there are just too many tools out there. And I think maybe for the next time I talk, I might change the title of the slide, of the entire deck, to what Aaron said: all tools suck, and there's no one tool to manage and solve all of our issues. And that poses a lot of problems and challenges when we need to try and decide what tool are we gonna select. There's also the challenges of what if we have different teams starting their infrastructure as code and DevOps journeys, implementing their own unique tools. How can we combine them? And of course, we all want to make sure at the end of the day, and that is something that I say quite a lot, and it kind of sucks. I worked in infrastructure all of my career. No one really cares about the infrastructure. Everybody wants the business to work and the business goal to succeed. And that, I think, is what we need to always remember. There are shiny tools out there, and as developer advocates and nerds, we want to deploy the shiny thing out there. But at the end of the day, what is critical to achieve the business goals is what is important. OK. So just a brief history of infrastructure as code. It started mostly in the beginning as just a collection of scripts and just automation running usually from your own laptop or centralized machine. I started my career with VMware, so my automation tool of choice was PowerShell. I still have a warm place in my heart for that. But then we saw the merge of configuration management tools like Puppet, Chef, then automation such as Jenkins for centralized pipeline to make sure that we have the central visibility. Ansible rose, especially with the open source community. Packer for managing machines. Terraform, and of course, the rise of Kubernetes, and more and more and more as we continue forward. So I think probably I covered that previously. So cloud-native architectures are what really driving IaC adoption. Doing what we used to do for infrastructure deployment even 5 years ago with some organization, it's really not scalable and agile by doing it with ClickOps or just scripts anymore. Okay. So just some of the consideration when you're trying to select the tool or tools we're using. What are the security and compliance requirements of your company, your organization, and your specific applications and potentially customers? How does that tool scale for the requirements and needs of your infrastructure? It might fit now, but as you grow, as more and more teams are starting to adopt that same IaC mentality, will that still be a tool that fits? Vendor lock-in. This is not just about a specific company that creates the code or the tool that you're selecting, but also think about how will it operate in a multi-cloud environment? And when I say multi-cloud, everything is cloud. Even if it's on-prem, it can still be bare metal servers. It can still be, or it can be just the shiniest new Kubernetes cluster running in the cloud of your choice. So this is something to definitely consider to make sure that you don't have tool sprawl at the end. Learning curve. The DevOps world is a really interesting one. I came from the sysadmin side. So I knew a bit of scripting, but the first time that I needed to run git commit, I was like, what the hell am I doing? What is going on there? Where is the UI that I can just see that everything worked there afterwards? Whereas someone, and I have those discussions, I think it's a bit of a clash that we see sometimes. Developers just want things to work. You want to run it, and you want it to work, and that's it. Sometimes on that road and process to get things to work, there's some things that tend to fall in between the cracks. Things like security, and things like security, and again, things like security. Things like backup, disaster recovery. These are things that, coming from the system administrator side of DevOps or the operations side of DevOps, are a bit more ingrained in the day-to-day life. So we need to think of that learning curve coming from both directions. There are some tools that are more system administrator focused and oriented. That will be much easier for people like me to implement. But there are some that are a lot more developer oriented, and that has, for me, for example, a higher learning curve. So community support, just because it works right now and just because it's open source and open source is awesome doesn't necessarily mean that if it breaks in day 3, day 4, day 100, someone will fix it. So the stability and maturity of the tool are definitely something that we need to consider. In addition, if it's a commercial tool, we need to factor in the cost of support and the cost of maintenance into our decision making. And lastly, open source versus company-owned. That is something, as we're having some discussions right now with the whole Terraform OpenTofu discussion, I wasn't very aware of it until we got into it, but there are some companies that, as a policy, either because it's a pricing policy, or it's a commitment that they have, they might have to leverage open source. Or it might be something that your organization is actually trying to avoid open source because there's not that much trust in it due to previous experiences or other issues. So cue up the Mortal Kombat theme song from the 90s. And we can just start having some fun here. We're just looking at some tools. This is going to be a broad overview because I think we would need an extra week just to cover all of the different tools that we can talk about. So how many people here are using Terraform? OK. How many people here tried to create, let's call it, more imperative configuration with Terraform? OK, I see a couple. So Terraform, of course, is, we wanted to open with that. It's I think, one of the most widely used tools and solutions out there. It is, as we all know, it's company-owned by HashiCorp. It has become an industry standard. It was one of the first ones to really bring in that multi-cloud approach for infrastructure as code. It's neutral, whether it's a cloud provider, or whether it's Splunk or Datadog, doesn't really matter. Really integrates well with a lot of systems and has a really, really big community and support out there. The potential complexity of it comes from the fact that it does use a proprietary, not a proprietary, but a domain-specific language. So there are some things that, if coming from the developer realm, that you're used to do in your own, if statement and loops, et cetera, that are just sometimes challenging to manage with a domain-specific language. In addition to, of course, learning the HCL itself. State management has always been something to think about, how we're doing it, how we're protecting it, how we're encrypting it. And of course, there is some vendor lock-in with HashiCorp, even if it's minimal. And next to it, we'll put the new one, right? It's OpenTofu, pretty much all the same things as Terraform. However, it is open source. It is new. So while there's a lot of things that are drop-in, there's this concern with something that is open source. How will this be supported? How will this communicate? Will there be divergence? So even though at the moment the choice between them seems pretty simple, there are definitely concerns. Just because it works right now, we need to think about the day ahead. And next, let's just talk about some more developer-oriented, I like to think about them, solutions out there. How many people are using CDK or CloudFormation for that aspect? OK. So CDK solves some of the issues that we saw with a domain-specific language, that it allows us to consume infrastructure as code using just programming language. And if you're coming from the programming world, this is really simple. Because if your whole developer team already knows Python, already knows Java, the scaling up and being able to implement the tool there's a much smaller learning curve. There are some challenges there. So that can be both a benefit and a downside. It's tightly integrated with AWS. There are ways to make it multi-cloud, but it's not natively integrated, and that just causes a whole sprawl of other issues. So we do have vendor lock-in and, of course, limited multi-cloud support. On the other side, we have Pulumi. How many people are familiar with Pulumi or have used it before? That's great. So Pulumi has the same developer familiarity with as CDK. It actually has a lot more. Ran out of space in the slide to show all of the different languages that it supports. But it is cloud agnostic. It's in a lot of ways, there's similarities to Terraform with state management. It's a bit more security oriented, but because it supports a lot of different programming languages, this does pose a security concern on its own because of all the vulnerabilities that might be in these packages. Some of the challenges there, and I think that is rapidly changing, is the community size and awareness of Pulumi. It is really a great tool. When I wanted to really get into Python, other than just starting writing Python projects, I picked up Pulumi, and that was kind of like my gate into learning that several years ago. And next, we can go to some of the more, let's call it veterans but still going strong, that are more configuration oriented. So if the previous tools that we talked about are really great at spinning up the infrastructure. So these are some of the things that we see Terraform, Pulumi being used a lot, is to bring up infrastructure. But from what you saw with the raise of hands before, not a lot of people use it for some non-declarative programming, just because it makes the code not repeatable, and it loses a lot of the advantages of selecting these languages. So Ansible is open source, even though it is owned by Red Hat and by proxy IBM. Supports mostly YAML. It is procedural, so it's always something to think about, and that is really a challenge for people coming from tools like Terraform, that it runs things in order, whereas Terraform builds its own dependencies in the back end. So you can have a mess of a Terraform file, but it will still work. Whereas with Ansible, it's running, you have to remember how what is the specific order that you need to run things, so you need to manage those dependencies. It's agentless, which is great. We don't need to install or maintain anything in our, on our guests. And one of the real big challenges is it doesn't have state management natively. There are solutions out there that provide it, but that's extra overhead. That means that there's no awareness of what is. Once we push the configuration, we don't know what has changed. In the same category, we also have Chef, that is kind of similar in how it works, but has a lot of differences. It's a bit more, call it older tool, came out in 2009, I believe. It's using Ruby. So if you have developers that are used to Ruby, that's great. I have never used Ruby, so that's not great for me, for example. It does work in a server-client configuration. It does have benefits because we can have more awareness of what's going on, but it does mean that we have to maintain those agents. There has to be a tool to deploy them. Then we need to think about how we manage those images and life cycle. So again, everything is kind of a double-edged sword. And this is, we're just scraping the surface here. What about application CI/CD, Kubernetes, Helm deployments, et cetera, and also the different CI/CD pipelines that we have? This is, if we try to pick the best one that can do it all, we're all going to fail. And I think that is what I want all of you to think about here, is that there's no single, unfortunately, best IaC tool out there. Because otherwise, I would come up and say, this is the one, and finish, and it would be an Ignite talk, and my voice would be a lot better, and that's it. But and I think both other speakers mentioned that planning is really important. So you need to, instead of just, because when I researched some things for this slide, for example, I went to both the best and worst place on the internet, which is Reddit, and everything has maybe 7 different opinions from the same person about 2 different tools. So the best thing is really the best for you. And just a short anecdote on that. I have an espresso machine at home. I love making coffee in the morning. And my brother-in-law wanted to get into it and asked me, like, which is the best one? And I was like, you can either go with this one, which is the best because it costs $15,000, or because you have 2 kids and you don't have time to do all the manual things that look cool on Instagram yourself in the morning, how about something a bit more automated? So, and also, it costs $400, so slight benefit in price there. So just because something is considered the best in class or something doesn't necessarily mean it will work the best for your organization. So ask those questions, like what are you currently using, and is there anything implemented already in your organization? What are you using for CI/CD pipelines? Where are you deploying? Are you mostly on-prem, cloud, specific cloud? Do you have any specific requirements? How are your applications going to integrate with this? And in addition, what is the unique combination of skills within your DevOps teams? Because, as I said, DevOps, it's a nice hybrid that comes with a lot of benefits and challenges because of the different background of the team members. So probably the best thing is to find tools that are great in specific category and combine them together. If there are things that, for example, Terraform is great at provisioning the infrastructure, the follow-up configuration might not be the best thing that it does. So then, of course, make sure that you potentially at that point hand it off to another solution like Ansible, like Argo, for example, to continue that configuration. So that way, you leverage the best capabilities from each tool type and then address the diverse requirement instead of trying to bolt on something that the tool is not supposed to do or wasn't designed to do. And then you end up spending a lot more time just to bolt it on and fix it with scripting. And again, understand where your organization is in its maturity. We like to look at it when we talk to customers and prospects in 5 different stages, all the way from ClickOps to full-blown platform engineering and self-service. And for each one of these phases, there might be certain things that you can consider to make sure that you, I'm blanking on the word, that you adopt the right tool and approach. So for example, the first phase, if you're doing a lot of ClickOps, implementing just in a very small scope, and depending on the size of the team, Terraform, OpenTofu, kind of like the leading approaches, because there's a large community, there's a lot of support. In next phases, of course, is trying to centralize those deployments. So see what is already in place with your CI/CD and integrations, either Jenkins, GitHub Actions we see a lot, or GitLab, for example, and make sure that you implement these solutions to integrate with those pipelines. And then the last one, of course, is full-blown platform engineering, self-service, that poses its own challenges, because if you give developers sometimes too much power, there needs to be guardrails in place, of course. OK, some trends that we're seeing. So a lot of GitOps, security posture. So make sure that a lot of these solutions support policy and codes integrations and security scanning, linting, things of that nature. So make sure you embed those security security tools and approaches directly into your infrastructure as code pipeline. And of course, cost optimization, it's something that is a challenge for every organization. So there's a lot of integration that you can place in your CI/CD pipelines to make sure that you can control the cloud cost as well. We talked about self-service, and of course, we have to put a bullet for AI because everything has AI right now. So there are some tools emerging out there. So in summary, there's no one single solution, and of course, the best tool and approach is what is best for your organization. So consider when you plan and when you select those, what is the maturity level? What is the technology stack that you're using? Both tools, application, clouds, regions, team skills, and of course, your use case. And as always, make sure that those things can work together in a pipeline so you don't have this manual dependency to trigger tools, and especially if you combine several together. And I think that's it. OK.
Great. Thank you very much.